Here we got a circuit with a supply voltage of 60 volts. We got a battery of 60 volt and an internal resistance of 0 ohm. Because we don't want to have a resistance in a circuit, so we have a perfect supply system of 60 volt. The load, we have 3 resistors and they are connected after each other so that the current which is going through the upper resistor is exactly the same current as for the middle and lower resistor. There is no possibility for the current to flow in any other way than through all the 3 resistors. And if we have that, we can say that the resistors are connected in serial. So if it is exactly the same current and they are connected after each other, the resistors are connected in serial. We can see the value for the 3 resistors are 5 ohm for the lower one, 15 ohm for the middle, and 20 ohm for the upper one. And also we can see that the current in the system is 1.5 amp. According to Ohm's law, we can say that the voltage drop or voltage potential across the upper resistor must be 20 times 1.5. It gives 30 volts. We can try to measure that, and we can see it is very close to 30 volts. We have a voltage drop of 1 millivolt because the program takes into account that we have a small resistance in the wire and therefore it gives a minor voltage drop. We can see that if we go nearby the supply system, we have 30 volts. So the upper resistor has a voltage drop of 30 volts. The next one has a resistance of 15 ohm, and if we multiply by 1.5, we got 22.5 volts. We can try to control that, and yes, we have nearby 22.5 volts. The lower one, we have 5 ohm, and multiply by 1.5, we got 7.5 volts. And it seems to be correct. So over here we have 60 volt for the supply system, and that must also be the voltage drop across all the resistors, because down here we have 7.5 volts. The next one was 22.5, and if we add these two together, we got 30 volts. We can try to measure that. Yes, we have 30 volts. And the upper resistor, we also got a voltage drop of 30 volt. So if we add that to the 30 volt, we have a total voltage of 60 volts across all the resistors. So the supply voltage must be equal to the sum of all the voltage drop in a serial connection. We can try to make some calculations, and we can see that the voltage for a serial connection is the total voltage of all the voltage drop of the resistors. Here we got 3 resistors, but we could have 5, 6 or 7 or how many we ever want. Instead of a voltage drop, we can say that it must be the same as the current times the resistance, according to Ohm's law. So instead of instead of the 3 resistors in the system, we can have one resistor which is called RS for equivalent resistor for the serial connection. Multiplied by the current, we got the total voltage for the serial connection, and that was the sum of all the voltage drop across the resistors, and that is I times R1 plus I times R2 plus I times R3. Since we got I in all places, we can divide with I, and then we got just Rs is equal to R1 plus R2 plus R3. It means that the total equivalent in a serial connection is just the sum of all the resistors in the serial system. If we go back to the circuit, we can see that we have 5 ohm, 15 ohm and 20 ohm. If we add these 3 resistors, we have a total resistance of 40 ohm. And it gives sense because we also have 60 volt and 1.5 amp. And if we divide 60 with the 1.5, we also can see that we got 40 ohm. We can try to adjust the upper resistance for 40 ohm and the 2 lower one to 0 ohm. So we just have one resistance of 40 ohm. And then we can see if the current will come to a value of 1.5 amp. So the upper one was 40 ohm and 2 lower one, we changed that to 0 ohm. So 40 ohm, 0 ohm, 0 ohm. And we can see that the current is 1.5 amp. So in a serial connection, the equivalent of a resistor is just the sum of all the resistors. Rs is equal to R1 plus R2 plus R3 and so on.